Welcome back. Hector from HelpMeGraduate.com. We're going to talk now about limits and one of the procedures to solve limits, which is known as changes variable. And I have been getting a lot of questions in the personal message thing on YouTube, and a lot of people are asking, is there a specific way to know what is the method that I have to tackle to solve the limit? And the reality is, well, limits I compare to these kind of disciplines that you have to do over and over again, like for instance tennis. I consider myself a decent of a tennis player. So when you're practicing tennis and you're with your training, your trainer, he's always throwing you balls like in the same spot all the time at the same speed, same pace, and you try to hit them over, until you perfect your stroke. And if he was to say throw the ball like a few feet away from you from the regular spot where he would throw it, then you would probably have to adjust. And at first you would likely start missing one of the shots because you're kind of used to perfecting a pace and a position and a speed. But when you get thrown off that, you have to readjust yourself and start doing that again. Okay, it's like you're basically doing the same thing all over again. So in essence, you have to keep practicing that new position. Okay, and then if you're getting the ball thrown at a couple of feet of you, then you have to work on your footwork and going back to the center and hit and so on. Okay, so with limits, it's exactly the same thing. Okay, when I was in college and I took the math class that dealt with limits, well, I found that this was kind of a major thing for me. Okay, because it doesn't matter how many limits I solved, they just kept coming in, and whenever I had one that I thought I had resolved, then I had another one that I haven't seen before. Okay, and there's always a new thing. Okay, so then I have to adjust and see if I could tackle those. Okay, so again, it's all about doing a lot of limits and doing a lot of practice so you can gain the ability to visualize how to solve them quickly. Okay, and change of variable is one of the most important methods that you have available to solve a limit. Okay, in my opinion, it may be the most important method, because when you see a limit, you're normally going to face a very weird expression, and you want to make that weird expression into something simple. Okay, so these are kind of not like the steps, but a little pointers that I'm giving you. Well, first of all, when you see a limit that has a radical involved or something like a very complicated expression, you may want to consider do a change of variable. Okay, because you want to turn something complicated into something simple. Okay, the objective of the change of variable is to get rid of the complication. Okay, remember also the following. A lot of people always forget about this. When you're doing the change of variable, okay, that you have x tending to xo or whatever, x tending to a constant, you also have to change that too, okay, to your new variable, which can be y or z or whatever. Okay, but that's always important. This changes, okay, this changes, and you have to take that into consideration. And finally, of course, like I said, it's like the tennis thing. Okay, keep practicing, try to make practice tend towards infinite. Okay, because it's all about consistency. Okay, so we're going to make an example, and I'm going to make a couple of more videos with more examples, because I know that this is a very delicate subject. So let me erase this, and we're going to go and deal with a limit involving change of variable. Let me grab it from my book. Let's see. Let's pick one. Okay. So let's say we have limit of x tending to 0 square root of 1 plus x minus 1 over cubic root of 1 plus x minus 1. And they ask us to solve that. Okay? So here's the expression. Here's where you have to realize where is the complication. What's going on with this particular exercise? Okay, well, as you can see, we have a radical, okay? And the good thing of it is that the argument of both radicals that we have is the same, okay? The argument is 1 plus x. It's whatever it's inside the argument. So we may have a hint that that may be what we want to apply the change of variable, okay? Now, here's what we have to think, you know. Here's the real challenging part, you know. How do we do the change of variable? What is it that we're going to replace? Well, we cannot do something like, for instance, y equals 1 plus x, because that's not going to help us at all, okay? It's just not going to be very helpful. I'm going to end up with something that looks like limit x tends to 0 of square root of y minus 1 over cubic root of y minus 1. And since x tends to 0, I have to change this into here. Since x tends to 0, this means that this x is 0, y tends to 1, okay? So at the bottom, y tends to 1. And it doesn't look like it did really anything, okay? It looks like pretty much the same. I still have the radical, I still have the cubic root behind. I mean, it didn't look like it helped at all. So let's see if I do something different, okay? Let's see what happens if instead of y equals 1 plus x, what happens if I say something like y equals 1 plus x? Better, 1 plus x equals y squared. What would happen then? Well, let's see. We would have then limit, and we're going to change this in a second, square root of y squared minus 1 over cubic root of y squared minus 1. And since x tends to 0, x is 0, y tends to 1. Does it look like we got rid of anything? Does it look like we solved something? Well, doesn't look like yet. Sure, the square root of y squared is y, so we can lose this. But we still have the radical right here, 2/3, right? So it doesn't look like we're doing anything so far. But it looks like we got rid of one radical. So if you think about it, well, if we got rid of one radical, maybe we can find a way of getting rid of both. How do we do that? Well, what happens if we do the following? 1 plus x, instead of equaling to y squared, what happens if we do y6? And then you're going to ask, 6? How does that going to solve that? Well, let's see. We're going to end up with limit of y6 square root minus 1 over cubic root of y6 minus 1. And since x tends to 0, y tends to 1. And now we got rid of both radicals, because the square root of y power to 6 is y cubed. And the cubic root of y power to 6 is y squared. And we can even write this down over here so you can visualize it. The square root of y power to 6 is equal to y power to 6 powered to 1/2. And this is equal to y cubed. And the cubic root of y power to 6 is equal to y6 power to 1/3, and this is equal to y squared. Okay? And this is what we end up with. And this looks a little bit nicer. Okay? There's no radicals. There's no complications. We got rid of the radical. We still haven't gotten rid of the indetermination. Okay? But we can get rid of it because y cubed minus 1 can be rewritten as y minus 1 times y squared plus y plus 1. And we can also rewrite y squared minus 1 as y minus 1 times y plus 1. Okay? So, this we rewrite as this, and this at the bottom we're going to rewrite as this. Okay? It's just notable products. So let's do that. And we're going to have y minus 1 times y squared plus y plus 1. And at the bottom, we're going to have y minus 1, y plus 1. And since y is different than 1, these two cancel each other. And there we got rid of the indetermination. And that's it. Okay? So we end up with limit of y tending to 1 of y squared plus y plus 1 over y plus 1. And now, since we got rid of the indetermination, we evaluate. Okay? 1, square 1, plus 1, 2, plus 1, 3, over 1 plus 1, 2. And this is the answer to the exercise. Okay? So let's do it again. What did we do? What is it that we worked on? Well, we did a change of variable, okay? We tried with a couple of simple changes that didn't work out because we weren't able to get rid of both radicals. But when we experimented with a higher degree of the variable, we were able to get rid of the lower radical, the cubic radical, and the square radical, okay? So all we did then was rearrange the limit. We also changed the variable right here, the limit when it's tending, and we just rewrote it, got rid of the indetermination, evaluated, and that's it. See you in the next video where we're going to do another exercise, okay?